In problem number 1, the first three terms of an infinite geometric sequences are given. The first task is to find the common ratio of the geometric sequence. To find the common ratio, we simply get the ratio between the term and its preceding term. So in this case, we have 3 raised to 9x over 3 raised to 10x. It could also be 3 raised to 8x over 3 raised to 9x. That gives an answer 1 over 3 raised to x or 3 raised to negative x. To find the general expression for u sub n, we simply substitute the values to the formula u sub n equals u sub 1 multiplied by r raised to n minus 1. So in this case, we have our u sub n equals 3 raised to 10x multiplied by quantity 3 raised to negative x raised to n minus 1. In this problem, u sub 2 of the geometric sequence is equal to 44 and u sub 3 equals 55. First task is to find the common ratio. So we will be using the formula we used in slide 1 or in the first problem. So r equals 55 over 44. There is a common factor 11. So the simplified form of this is 5 over 4. Letter B, we find the first term of the sequence, u sub 1. We will be using the formula u sub n equals u sub 1 multiplied by r raised to n minus 1. Substituting the values, we have 44 equals u sub 1 times 5 over 4 raised to n minus 1 or 2 minus 1 is simply 1. Simplifying the problem, our u sub 1 equals 35.2. Find S sub 5 or the sum of the first 5 terms of the sequence. Substituting the values for the formula of S sub n, we have S sub 5 equals 35.2 multiplied by 5 fourths raised to 5 minus 1 over 5 fourths minus 1. That gives us an answer 288.8875 or 288 and 71 over 80. This is an exact answer. In this problem, the general formula for a sub n is given, and it is equal to 32 minus 7n for all values of n elements of positive integers. In letter A, we're asked to find an expression a plus 1 plus a sub 2 until plus a sub 12 using sigma notation, and also we are asked to find the value of the sum. So for the first part, this is really an easy problem. So we have S sub 12 equals summation of the formula 32 minus 7n, where n equals 1 until 12. There are two ways by which we can find the sum. The first one is by using the formula which you can find in your booklet for arithmetic series S sub n. But these will require us to find our u sub 1 and our d. So I already computed the first three terms and found it to be 25, 18, and 11 respectively, and this gives me the common denominator, which is equal to negative 7. So substituting the values of the formula where n equals 12, our sum for the first 12 numbers will be equal to negative 162. Another way of doing this is using the catalog in your GDC. You are going to encode the values as you can see here. This is a screenshot of my GDC. And then when you hit enter, that will already give you the answer, which is equal to negative 162. So for letter B, same way. But then we are asked to write an expression in sigma notation from the fourth term, or the sum of the terms from the fourth term until the 15th term. So it's going to be the summation of the general formula given, which is 32 minus 7n from n equals 4, that's our starting term, until the 15th term. So I use again my GDC using the catalog. This gives me an answer which is equal to negative 414. Another simple task is to find u sub 4 and sum of the first five numbers in a geometric sequence which has u sub 1 equal to zero point 0.5 and r equals 3. So normally we write the formula, then the substitution. So here in this slide, I got rid of the formula. You can look it up in your formula booklet. So I'll have u sub 4 equal to zero point 0.5 times 3 raised to 3, and that gives an answer which is equal to 13.5. For the sum of the first five uh, sequence or first five terms using the formula u sub 1 multiplied by r raised to n minus 1 over r minus 1, substituting the values, you have it here, and that gives a sum of 60.5. Okay, that is very easy. That's why they are given only 1 mark each. So an arithmetic sequence is the same u sub 4 and s sub 5 as the geometric sequence below. So what we're saying here is the fourth term of the arithmetic sequence is equal to 13.5, and the sum of the first five arithmetic series is 60.5. Now we are asked to find u sub 1 and d. So we can find u sub 1 through the formula u sub n. So by substitution, it's equal to 13.5 equals u sub 1 plus 3d. So our u sub 1 is 13.5 minus 3d. That's not the final answer yet because we need to find the actual value of u sub 1. So we make use of our summation for five numbers. So you can see in your formula booklet, there are two ways by which we can find the arithmetic series. So the formula used here is n over 2 multiplied by 2 times u sub 1 plus n minus 1d. So by substitution, this will give me uh, a difference of 7 over 5 or 1.40. So we're done with our task in B of finding the common difference. Now we find u sub 1. So going back to u sub 1 equals 13.5 minus 3 times d, we substitute the value for d, which is 1.40. So u sub 1 is equal to 9.30. The terms of the arithmetic sequence are given as an expression: x plus y, 2x plus 3, 6y minus 1, and 9y minus x. We are asked to find the values of x and y. So the first thing that we can do is to find the difference, which we know is equal to the term minus the previous term, or u sub n minus u sub n minus 1. So if we're going to do that, then we'll have a difference of second term and the first term. So that's 2x plus 3 minus quantity x plus y. Simplifying that, we'll have x minus y plus 3. Let's make it our equation number 1. We can do the same for third and second term. The difference will be 6y minus 2x minus 4. Let's make it equation 2. And then again, let's find the difference between fourth term and third term. And simplifying that, we'll have 3y minus x plus 1. Let's call it equation 3. Now we know all the differences must be same all throughout this sequence. So let's say d equals d. So 1 could be equal to 2, 1 could be equal to 3, 2 equal to 3 also. So any of those equation. I made d equals d for equation 1 and equation 2. And simplifying that, I'll have 3x minus 7y plus 7 equals 0. And I call it equation 4. And then I have d equals d again for equation 1 and equation 3. And that gives me the simplified form of 2x minus 4y plus 2 equals 0. I call it equation 5. Now, I hope you're familiar with this kind of equations. So how do we solve equation having two variables or equation of two variables? 3x minus 7y plus 7 equals 0 and 2x minus 4y plus 2 equals 0. We can use systems of linear equation. So I think in grade 10 or grade 9, you learn how to solve systems of linear equation in one variable and two variables. There are two methods by which you can do that. One is by elimination and the other is by substitution. Now, I did not show that anymore. I did not show the algebraic solution to this. I just write a value for x equals 7 and y equals 4. But you can, of course, you can do that in your paper, or you may use other method, which will be shown in the next slide. We solve for x and y using systems of linear equation. There are two ways by which we can do that. Solving it using substitution or by elimination. So that is an algebraic process. Another thing is just using your GDC. You can find systems of linear equation in this command menu, algebra, and systems. You're going to encode the values or the equation. First equation is 3x minus 7y plus 7 equals 0. And then the next equation is 2x minus 4y plus 2 equals 0. Okay. But upon hitting enter, it will give you the result for x and y. X equals 7 and y equals 4. To continue, for letter B, we're asked to find the largest value of n such that the sum of the first n numbers is less than 800. So we can use the formula for S sub n, and then we will be required to find u sub 1 and d. Okay, so substituting for previously we have x equals 7 and y equals 4. So we can find already the first four terms. I already done the computation here. The first four terms are 11, 17, 23, and 29. That is using again x equals 7 and y equals 4. So this will give me a difference or common difference of 6. So what we need is to have our S sub n less than 800. So by substitution, we have n over 2 because we really don't know what n is. So we retain that variable. And then our u sub 1 times 2 is 22. And then our n minus 1 times the 6n minus 6. Okay, that expression must be less than 800. Or in your calculator, you will use numerical solve, but you change less than to equal. That gives you the value of n equals 15.050941. So your question is whether your n is 15 or 16. N is equal to 15. Actually, this will give a sum of 795. If you use n equals 16, that will give you 896, and that's over 800. So for this number, the value of n, or the value of n is equal to 15. In the last problem, we have a geometric sequence having the third term equal to 160 and r equal to 1/4. So to find the first term, we can make use of the general formula, which can be found in your formula booklet. U sub n equals u sub 1 times r raised to n minus 1. In the test, it is always best to write the formula before the substitution. So what I have here is a substitution of values. 160 equals u sub 1 times 1/4 raised to the second power. To simplify, our u sub 1 equals 2560. For u sub 6, we use also the same formula. And my substitution here is that u sub 6 equals 2560 multiplied by 1/4 raised to 6 minus 1. Okay, so our u sub 6 is equal to 2.5. Part B is just like a given away question. We are asked to find the sum of the infinite sequence. So we follow the formula u sub 1 equals u sub 1 over 1 minus r. We already computed u sub 1. So the danger here is if u sub 1 is wrong, you will not be able to get the sum of infinite sequence correctly. So u sub 1 equals 2560 and 1 minus r or 1 minus 1/4 equals 3/4. Simplifying this, we'll get the sum equal to 3,413 and 1/3. This is an exact answer and it's also equal to 10,240 over 3. For decimal, you'll have 3,413.333, and if you're going to write that in three significant digits, it will be 3,410. For part C, the first and the third terms of the geometric sequence corresponds to the seventh and the ninth term of the arithmetic sequence. So you can see here, I put the seventh and the ninth terms in the arithmetic sequence. So to find the common difference, I can make use of the formula u sub n, where u sub n again equals u sub 1 plus 2 minus 1d. So my u sub 9 is 160, my u sub 7 is 2560, and n minus 1 is 2 times the difference. So solving this will give me a difference of negative 1200. Part 2, find the first term of the arithmetic sequence. So again, same formula for u sub n. And the substitution will be 2560 equals u sub 1 plus 6 times substituting the value of the difference, negative 1200. So solving, simplifying, using your GDC, the u sub 1 will have, or the first term will have a value of 9760.